Hi, I'm Bob Easton. I'd like to show you my treadle lathe today. We'll walk on over here and get a closer look at a few aspects of it. There, hanging on the wall, are the plans by Stephen Shepard from Full Chisel blog. There are 8 sheets of plans there. Stephen is a 19th century woodworking reenactor, and he dates this particular lathe design in 1805. Now, I chose this particular lathe after reviewing about 77 versions of lathes on the internet. I liked this one for 2 reasons. One, it's compact with the wheel up here between the uprights instead of sitting way back as it does in some lathes. The other aspect of it is the flywheel is supported between these 2 uprights, and that way I favor having bearings close to the wheel rather than having the wheel set on a cantilevered axle and hanging off the edge of one of those uprights. The wheel is 24 inches in diameter. The core of it is 2x8 and the face of it is 1x8, and it's all drilled and glued together and made round on a bandsaw. I'd like to show you how it's attached. There are plumbing flanges on either side of the wheel, and the plumbing flanges have 4 screws going through them. They're going through tapped holes and then are going into dimples in the axle. So with that kind of arrangement on either side of the wheel, it is solid upon the axle and not slipping around anywhere. The second improvement I made to the lathe was to replace the crank. I originally built a crank of wood, and I knew this wasn't going to last very long, and a friend of mine from Indiana popped up and said, "Bob, that's not going to last very long. Let me make you one of steel." So Roger Davis made this crank out of a block of steel. It's a press fit on the shaft, a 1/2-inch shaft, and is locked down tight with those clamping screws. It stays right in place, doesn't move, performs wonderfully. Going a little bit further along the drive, we can see here we've got a Pitman link, which is simply a piece of oak wood. The Pitman link has a couple of nice things. Down at the bottom, there's a lot of room for play, and as we look up at the top, it's got a slot in it. So those features are there so that I can jump and wobble around a lot on the treadle without causing the actual lathe operation to be jerky. Behind the treadle is a parallel link that keeps the treadle out here parallel to the axis of the lathe. These particular joints are just a snug fit, not too tight, but free enough to move. Down at the other end of the treadle is a pin sticking in that block for the pivot point, and it also is pretty loose. Okay, let's look at the head end of the lathe now. When Stephen designed his lathe, talking about an 1805 lathe, they were dealing mostly with metal rods and push-through wooden posts. I wanted something that would run a little bit smoother and perhaps last a little bit longer, and I decided to use ball bearings and a rolled steel bar. This is a 5/8 inch steel bar. It's that size because it's the size used in shopsmith lathe spindles. Consequently, there are a number of adapters readily available for it. For example, here is a drive center, fits on with a set screw, and here is an adapter which is a 1 inch by 8 turns per inch adapter, upon which we can add face plates or lathe chucks or whatever you might want to mount in this lathe. Here's a ball bearing, takes up radial load on the shaft, and back here at the other end is a ball bearing for radial load, and behind the ball bearing is a thrust bearing which takes up axial load. The belt is 2 inches wide. It's from Tandy Leather. Tandy sells these belting strips in 72-inch lengths. I needed to buy 2 to to put together a total of 105 inches to go around the both wheels. 105 inches. Imagine a fellow wearing a belt that size. He would be quite a sideshow attraction. The white belt's very nice because it has lots of surface to grip both of the wheels. And I did not make an idler for it. Actually, it is fairly loose. And because of the broad surface inside, that seems to be enough. It does not have to be extremely tight to provide efficient and reliable drive. The second change I made to this lathe after using it a few days was to take the wedges that hold the tool rest and the tail puppet in place, take those wedges and round off the bottom of them, because when you see the lathe in operation, you find out that a leg comes up here fairly close to these from time to time, and it's nice to have rounded corners. So let's look at the tail puppet. The bright shiny piece there is a sleeve, and it's a sleeve that is a number 2 Morse taper, and it is simply press fitted into a 1-inch diameter hole in the puppet. The live center that's there is a number 2 Morse taper live center, and with this kind of arrangement we can change out, put other sorts of devices and adapters in there. The third change I made to the lathe after the original build was to change the tool rest some. It started off with a fixed height tool rest, and that wasn't quite useful enough for the variety of turning that I would like to do. So I cut off the top of it, made a new piece here that has a couple of slots, and it can be adjusted up and down on that pair of screws. The tool rest is affixed to the lathe with a bridle, which is oak. The tool rest itself is oak, and then just hammer in the wedge to tighten everything up. It has a good bit of freedom. It's not yet good enough for faceplate turning, but we will make something else to do that job. So there you are. It's an overview of what the lathe looks like. And of course, the handy thing to have nearby is a good old rubber mallet so that we can pound in those wedges.